We have now arrived at one of the most interesting, probably one of the most fun parts of the course, and that is where we're going to be looking at graphs. As you, I'm sure, already know, in statistics, graphs are used quite extensively, and with good reason, since they're able to summarize a lot of information in a very visual, very direct, very concrete way. Now, we're not going to go in detail through a lot of different kinds of graphs, but we're going to be looking at some of the most common, the most useful, the most frequently encountered graphs. And as we do that, I'll try to point out some basic criteria that you should think about when you're analyzing, reading graphs, or even choosing a graph to make. I will not spend a lot of time describing in detail how to make these graphs, except with the exception of box plots, which we'll do in the next class. But again, I'll just highlight some important features. For instance, we're starting with a pie chart. You have all seen pie charts. This is a typical pie chart. And of course, each of the colors corresponds to a potential value, and it's done in different colors. And the size of each of the slices represents the proportion of the observations in the sample that correspond to that value. So, for instance, in this case, I constructed this pie chart for a sample that had 12% of the data having value A, whatever A was, and 25% had value B. Notice that the 25% corresponds to about a quarter of the circle of the pie, and that's as it should be. And then C was observed in 33%, so again that slice covers about 1/3 of the whole pie, and then the last one covers 30% for the value D. And if you notice, if you add up those numbers, you'll end up with exactly 100%. That's the whole idea of pie charts. They divide the whole set, the whole data set, the whole pie, if you want. They slice it up into the different proportions that were observed for each value. So, pie charts are very simple. They're very well known. Probably you have seen them from grade 1, and you've been using them since grade 1. And they're very attractive. Again, both the shape and the use of colors, the fact that we can add percentages, frequencies, and all kinds of things. We can add legend. We can in fact have many variants. You may have seen exploded pie charts, 3D pie charts, and whatnot, and pie charts that actually look like real pies, and so on and so on. But there is an important point to be made here, and that is that pie charts have some very strong limitations. For one thing, they're really suitable only for nominal data. We can theoretically use it also for other kinds of things, for ordinal data, for even for ratio data if you want to. But for any one of those situations, there is definitely a better graph that one can use. It's a very basic, very simple graph, and as such, it does not really convey a lot of information. But even when we are dealing with nominal data, we are going to run into troubles with pie charts. So pie charts, because of their popularity, you may want to use them, but keep in mind that because of their technical weaknesses, you may want to stay away from them and use something else. But what do I mean by technical weaknesses? Well, first of all, a pie chart is a very rough visual representation of the data. It does not really convey a lot of information. It has the slices ordered in some way, but the slices, except that for the ones which are adjacent to each other, cannot be compared very easily, and even when they can, it's hard to visualize easily the size of one slice as compared to another one. So, for instance, in a pie chart that looks like this, well, which one is the larger, which of the smaller, thinner slices is in fact bigger than the others? And there are two slices which are fairly large, that look almost of the same color. It's not quite the same color. If you look really carefully, you'll realize that they're slightly different colors, but are they? Who knows? Very difficult to do if you don't choose the colors properly. Which one is the biggest one? Probably you can figure that one out. What's the second biggest? Maybe you can figure that one out too. What's the third biggest? What's the smallest? The second smallest? Very difficult to figure out. Keep in mind that with pie charts, there is always a better option that you can use, okay? And then they're often used inappropriately. For instance, look at this chart. I've seen charts like this several times. Can you spot what is wrong? Can you figure out where it came from? I'm going to leave that to you as an exercise. Just remember, the percentages there play an important role in the mistake of that chart.